Students, welcome to the third session of Chapter 5 Friction of Class 8th of Subject Science. Today we will start with next type of friction, that is sliding friction. Students, you already know that when a force is applied on a body at rest, a force of friction called static friction comes into play. And this friction opposes the applied force, and it is also called self-adjusting force as it increases with increase in applied force, and it can be increased only up to a certain maximum value, which is called limiting friction. When applied force is increased beyond the limiting friction, then body begins to slide over the surface on which it was resting. And after this, it is the force of sliding friction that acts between the two surfaces. Now this sliding friction means now object starts moving, so it is also a type of kinetic friction. The force of friction is little less than limiting force of static friction, means sliding friction is less than static friction. So the sliding friction is the force of friction between two objects when one of them is sliding over the surface of other. Look at the diagram. Two examples are given of sliding friction. In first, a boy is doing skiing on the snow, and in second, batsman, he is sliding on pitch to prevent himself getting run out. So these are the examples of sliding friction. Next type of friction is rolling friction. The force of friction that comes into play when one body rolls over the surface of another, and you must have seen the examples of rolling friction on bus stand, railway platforms and airports, that small children are able to carry along their suitcases easily because wheels are fitted with the heavy luggage, and this wheels, they help to produce rolling friction, and this rolling friction is less than sliding friction. To that rolling friction is less than sliding friction, different activities are given in your book. In the first activity, it is for the sliding friction. In activity, what we have to do, we have to take a wooden tray and a block and place it near the one edge of tabletop. Keep a cylindrical pencil rod on the opposite edge of the tabletop. Look at the diagram using drawing pins. Make sure the pencil rod is free to rotate about its axis between the drawing pins as shown in the figure. Now take plastic lid of a jar that you can get in your kitchen. You can ask your mother to give you plastic lid of a jar and make holes in them and put 3 pieces of string through the holes. Look at the diagram like that, and you can do this activity in your home also and tie them together. Next, tie them to a longer string from which we can suspend the plastic lid freely. Tie the other end of longer string to the wooden tray block such that it passes over the pencil. Take some marble. You can take pebbles also. Add these marbles in the plastic lid one by one until wooden tray blocks start just sliding. Note down the number of marbles required. The number of marbles put in the plastic lid is an indicator of the magnitude, means amount of the limiting force of friction, means when this sliding starts. So you can calculate the static friction and limiting friction by calculating the number of pebbles that you will put in the lid. Once the wooden tray block begins to slide, gently take out small marbles from the plastic lid. What we observe? Pick up another such small marble. Does the tray block stop sliding over the surface of tabletop? What happens when we remove a sufficient number of marbles from the plastic lid? In first case, when tray block just begin to slide, the force of friction is limiting or maximum value of force of static friction. Once the tray block begin to slide, the friction that exists is sliding friction. It means it is easier to keep on moving an object when it is already in motion than to start it from the rest. Means when you have to move an object, you have to put more pebbles on the lid, and when it starts sliding, then if you take out the marbles from the plastic lid, the tray, it will keep on sliding and move to the other end of the table top with same speed. It shows that sliding friction is slightly less than static friction, and it also shows that it is easier to keep on moving an object which is already in motion than to start it from the rest. Now what about the rolling friction? For this another activity is given in your book, and for this activity we require same material that was required in the previous activity, but we require few more pencils. Now what we have to do, take a few pencils which are cylindrical in shape, place them parallel to each other on the tabletop. Now place a wooden tray block over them as shown in the figure. Repeat the steps of previous activity. What we observe? We find it easier to move tray block in this way than to slide it. We can come to know it by noting down the number of marbles that are required in this case, and we can compare the number of marble by previous activity. Then we can observe that less number of marbles are required to move this wooden block than the sliding it on the table. So this shows that rolling friction is less than sliding friction. Wheel, a revolutionary invention. Rolling friction is much less than the sliding friction. This causes the invention of wheel. You know that we can move a heavy object by using wheel easily. So static friction, it is more than sliding friction, and sliding friction is more than rolling friction. The wheel has been considered one of the greatest inventions in the history of mankind. It is much easier to cart a heavy load put on a trolley with wheels than to push it. Wheels are used extensively in daily lives for transportation. They save labor and energy to great extent. This is because of the reduced friction associated with rolling. Now answer the following questions. Define sliding friction and rolling friction. Question number 2. Name the kind of frictional force that comes into play when a book is kept on collection of cylindrical pencils. Question number 3. Explain why sliding friction is slightly less than static friction. You have to write answers of these questions in your rough notebook. And that's all for today. Thank you and have a nice day.